Welcome to the training module on the 8-bit PIC microcontrollers by Microchip Technology. This training module will introduce Microchip's 8-bit PIC microcontrollers. To help you understand Microchip's product line, let us use a very common application example. In this example, we have Nick's watering his garden every day. Every morning, Nick wakes up and waters his garden for about 10 minutes. This he repeats day after day after day. Well, the challenge Nick has is, what if he were to go on a vacation, or fell ill, or was just lazy one morning? Wouldn't it be nice if he could replace himself with an automated system which would do the same function every day? All he needs is a sun detector, a valve opener or closer to allow for water control, and a timer to do the 10-minute watering. If we replace Nick with a PIC MCU, then here is what it would look like. In this example, a simple PIC MCU with one input for the light detector and one output for a water valve controller is all that is needed as an input or output. An internal timer is included inside the PIC to keep track of time. The light detector detects the sunrise. The valve is then open for 10 minutes, after which it is shut. This can be repeated every day with no intervention from Nick. For this simple application, the ideal part would be from the PIC10 or 12 product line. These PICs are 6 and 8-pin devices which have very small footprint, are low cost, easy to program, and have enough I/O, program data memory to accomplish simple tasks. As shown in this block diagram, they have half to 1 KB of flash program memory, up to 128 bytes of RAM, and 256 bytes of EEPROM. They all have 4 and or 8 MHz internal oscillators, and some have 10-bit A/D converters on them, along with comparators, input capture, and output compared PWM. These parts can be programmed using C. These families offer low pin count and small form factor. Packaged in either a 2x3 DFN or a 6-pin SOT23, the families both provide a 4 MHz and 8 MHz internal oscillator, in addition to an integrated analog comparator, 10-bit A/D converter, input capture, and output PWM. 16 products are available with 2 KB of flash and 128 bytes of RAM and 256 bytes of EEPROM. Coming back to our example of Nick and his garden watering system, let us provide a new challenge to Nick. Nick's wife wants to add summer crops to the garden. Nick now has to take care of these issues to the simple 10-minute watering system that he initially built. Summer crop needs different watering amounts and watering at different times of the day. One way he could solve this issue is to build many of his simple systems to take care of each summer crop. Alternatively, he could redesign his system and build a programmable unit which will take care of all the watering schemes needed. A typical programmable unit would need a keypad to do data entry, an LCD to view the data entry. It would still need a light detector and a valve control unit like the simple system that Nick designed earlier. It could include a serial interface connected to a computer, which would make programming the system easier. In a bullet format, he now needs an LCD display and keypad, many more outputs and inputs to handle more external interfaces. He requires analog inputs to interface to light, humidity, and other sensors, and finally he needs a serial interface like RS-232 or USB. Obviously, the PIC10 or 12 that Nick used previously will have to be upgraded to a bigger and larger PIC. Which brings us to the PIC16F family of parts. The blocks in red are the ones which have new and or improved capability from the PIC10 or 12 family of parts. Here we will notice larger flash data and EEPROM memory. The core remains more or less the same, but they have more serial interfaces like UARTs, I2C, SPI, larger packages, devices up to 64 pins, and more timers and other peripherals. Some PIC16F family products can also drive LCD glass directly. Lastly, interrupt control is now available on the family to allow for quick response to external events or actions. This family is available in larger pin count devices up to 64 pins and more than 75 products running at speeds of 20 MHz. These MCUs offer more flash, RAM, and double EEPROM. More analog inputs include internal op-amps, comparators, and ADD converters. These devices also feature various serial interfaces like UART, SPI, I2C, and USB, digital input and output controls like capture, compare, and PWMs, direct LCD drivers. All PIC16F family products can be programmed using C. With all these capabilities, NIC can easily build a programmable water system. A latest addition to the PIC16F family of parts is the enhanced PIC16F product line. The improvements include 10 new products with larger pin count and running faster at 32 MHz, larger flash and RAM for larger programs and programming using C, more peripherals like dual UARTs, dual SPI, and dual I2C. With most new designs being written mainly in C, the new enhanced PIC16F devices have been redesigned to meet the larger program needs and run faster. If for some reason NIC runs out of space for his programmable system, he could easily move to the enhanced PIC16F family and get more flash RAM for his program. Please note the enhanced core is identified by the 1XXX after the PIC16F. Back to our application example with NIC's water system. Let us now offer another challenge. What if NIC wants now to connect his system to the internet and monitor his watering system remotely when he's working? Well, most of the other peripherals would remain the same, that is, the keypad, LCD, input and output sensor interfaces, etc. Now he has to add internet connectivity to his system. Does he need to upgrade his system? In order to meet the connectivity requirements, let us now introduce the PIC18 family of products. Again, the changes are all highlighted in red blocks. First, connectivity to the internet is not trivial, so more flash and data memory is now available to accommodate the requirement. The core itself has been improved to include a faster CPU running at 16 MIPS for faster operation. Larger pin count up to 100 pins devices are available. Additionally, peripherals like USB, Ethernet, and CAN are now included in this family. A new module called the Charge Time Measurement Unit, or CTMU, has also been added. The CTMU is a microchip patented peripheral which allows the designer to measure small changes in capacitance and time, and also generate short pulses. Lastly, a peripheral pin select peripheral has been added, which allows a designer to reconfigure digital peripherals to different pins on the device. PIC18 has more than 165 parts, with large flash and RAM for bigger programs and larger applications written using C. These devices feature advanced peripherals like USB, Ethernet, and CAN, higher resolution ADD converters up to 12 bits, new charge time measurement units, integrated LCD drivers to drive glass directly, peripheral pin select peripherals which can reconfigure digital input or output to different pins on the device. With such a device, NIC can now build his programmable watering system and connect to the internet to monitor his watering system. Now let us look at what hardware tools are available from Microchip to help you accelerate your design. Depending on the complexity of your application, you have a three-tier solution for selecting a debugger. The top-of-the-line debugger from Microchip is the MPLAB Real Ice. This is a high-performance real-time debugger with unlimited debugging capability and real-time data monitoring features. The middle-of-the-road solution is the MPLAB ICD3. This debugger offers limited debugging and real-time data monitoring features. At the low end of the spectrum is the PICKit 3 Debug Express, which is Microchip's entry-level debugger. For a simple application like NIC's first watering system, NIC could very easily have used the Debug Express. For his next design, where he built a programmable watering system, he would be wise to choose the ICD3, and for his complex Ethernet connectivity design, he would have done well to choose the real ICE debugger. In order to jumpstart the hardware platform for your design, Microchip offers a whole list of starter kits. The most important feature offered in a starter kit is that a debugger is included as part of the starter kit. The starter kit is low cost and has some hardware and prototyping area for customer to evaluate a PIC product. All starter kits are supported on MPLAB, and most are bundled with a C compiler, making it easy for the end user to program and evaluate the PIC device. The first starter kit is the PICKit Starter Kit. This comes with a PICKit debugger, a demo board for 8, 14, and 20 pin count PIC16F devices, 12 lessons to easily learn how to program the part provided, which is the PIC16F 690 device, a light version of the high-tech C compiler, and an MPLAB IDE. This would be an ideal starter kit for Nick to begin development on his first system. A slight upgrade to the PICKit Starter Kit is the PICKit Starter Kit. Microchip's PICKit in-circuit debugger or programmer uses in-circuit debugging logic incorporated into each chip with flash memory to provide a low-cost hardware debugger and programmer. Again, tutorials and lessons to program this part are provided along with a light version of the C compiler. This would be a good starter kit for Nick to use his programmable watering system. Another starter kit which would help Nick design his programmable unit would be PIC18F 4xK20 Starter Kit. This demo board comes with an output LED display. Again, it has the lessons and demos as well as the C compiler bundled with the board. For connectivity related application, the PIC18 Starter Kit is a very good option. The debugger comes built on the board and is powered by the USB cable to the PC. An output LED display is available along with capacitance touch keys built on the demo board. Full demos on USB connectivity are available for this board, and it is shipped with a free C compiler. This would be ideal for Nick to design his programmable watering system with connectivity using USB. In summary, Microchip offers a wide range of 8-bit products from simple to very complex. Microchip offers easy and low-cost hardware and software solutions in low-cost starter kits and free C compilers for easy code and application development. Finally, Microchip meets Nick's needs as a one-stop for his plant watering application.